Okay, so let us continue. Permanent hardness. So it is due to the presence of soluble salts of magnesium and calcium in the form of chlorides and sulfates. So earlier we learned that temporary hardness was due to the presence of bicarbonates of calcium and magnesium, and now permanent hardness is due to chlorides and sulfates of magnesium and calcium. Okay, so permanent hardness is cannot be removed by boiling, unlike temporary hardness. So let us see the methods by which temporary hardness can be removed. Okay. So don't take the highlighter. So treatment with washing soda, sodium carbonate. So as we learned in the S block chapter, we will learn about the sodium carbonate or the washing soda. So treatment with washing soda. So washing soda reacts with soluble calcium and magnesium chlorides and sulfates in hard water to form insoluble carbonates. So let us see, like in the first part also in the temporary hardness, we observe a common factor here, that is the formation of insoluble carbonates. Okay, so we need to form insoluble salts such that we can filter it out and purify the water. So the main aim remains to make insoluble salts. Okay, so in making the insoluble salt is a final aim. So treatment with washing soda or sodium carbonate. So washing soda reacts with soluble calcium and magnesium chlorides and sulfates to form carbonates which are insoluble in nature and other salts. Okay, so washing soda reacts with calcium or magnesium chloride, forms calcium and magnesium carbonate which is insoluble, can be filtered off and can form NaCl and forms NaCl. Okay, and when it reacts with sulfates, calcium and magnesium sulfates, and in washing soda Na2CO3, it forms carbonate, that is sodium or calcium or magnesium carbonate and sodium sulfate. Okay, sodium sulfate is formed. So the first method is treatment with washing soda, sodium carbonate, of course. So the next method is a very famous method, it is Calgon's method. Okay, however you pronounce it. So sodium hexametaphosphate Na6P6O18 is commercially known as Calgon. Okay, this is important. So I'll put a note here. I'll put a note here that is important here. Okay, so this is important. So Calgon's method. So sodium hexametaphosphate. So sodium hexametaphosphate. So by the name suggests it's sodium hexa means 6. So Na6P6O18. So metaphosphate is P6O18. So Na6P6O18. It is a commercially known as Calgon, and its chemical name is sodium hexametaphosphate. So when sodium hexametaphosphate or Calgon is added to hard water, the following reactions takes place. Okay. So this is a complex reaction that takes place. This is not important. Do not like mug up this reaction. These reactions do not come in the exams. So what's the main thing that is we need to note from here? The complex contains anion. Complex anion keeps the magnesium and calcium ions in the solution. Okay. So the thing that I notice is that Na6P6O18 disintegrates into sodium ion. Okay, disintegrates into sodium ion, and that sodium ion and forms Na4P6O18 2 minus. Okay, it forms this compound. So this compound, when reacts with calcium or magnesium ions, it replaces that and forms sodium salts of that sodium salt of this compound. Okay, sodium salt of calcium, sodium hexametaphosphate, and this thing is soluble in water. When this reacts with any other salts, it becomes insoluble in water, and we can easily filter this off. Okay, so this thing is not, the reactions are not so important. Just remember the chemical name, Calgon sodium hexametaphosphate, and it is used in the removal of permanent hardness. This is just that you need to remember. No need of remembering this long reactions, because this doesn't come. You can just remember that what's complex that is formed after removal of 2 Na plus. So there's earlier there were 6 Na plus. So if 2 Na plus are removed, so 4 Na plus remains. So Na4P6O18. This compound remains, and this ion actually reacts with the other salts. Okay, the salt, this M depicts calcium and magnesium ions. Okay, so this M depicts calcium and magnesium ions, and this ion reacts with calcium and magnesium ions, forming the salt, insoluble salt. Okay, now comes the third point, a third method, that is ion exchange method. This method is also known as zeolite permutate process. So this is very important. Ion exchange method is also known as zeolite permutate process. Okay, so hydrated sodium aluminum silicate is zeolite. So earlier we learned the chemical name of calgon, that is sodium hexametaphosphate, and now the chemical name of zeolite is hydrated sodium aluminum silicate, NaAlSiO4. This is the chemical formula of sodium, that sorry, zeolite or permutate, hydrated sodium aluminum silicate. Okay, so this AlSiO4 group, we replace it with Z. Okay, for the sake of simplicity. So when this is added in hard water, the exchange reactions takes place. So NaAlSiO4, when reacts with calcium and magnesium ions. Okay, so when sodium NaLSiO4 reacts with calcium magnesium ions, replace, like, see, this exchange is taking place. See, this calcium and magnesium ions replacing Na, so sodium ion. So this is exchanging sodium, and calcium and magnesium is taking its place. So it is known as exchange reaction. See, the exchange reactions takes place. So Ca or calcium or magnesium, Z whole 2, that is AlSiO4 whole 2. For the simplicity, I am taking Z. So plus 2 Na plus, because this Na plus is getting replaced by calcium and magnesium ion. This forms an insoluble salt. Okay, this forms an insoluble salt. So permitted and zeolite is said to be exhausted, and all the sodium in it is used up. So this is important. So when is like the permitted zeolite said to be exhausted? That is when all the sodium ions are used up. Okay, so it is regenerated for further use by treating with an aqueous solution of sodium chloride. So you might get a question, like a rare chance of getting a question is that you can ask in board exam, that how it is regenerated, how zeolite is regenerated. So here we form this compound. Okay, so MZ2 or MgZ2 or CaZ2. So this compound, when reacts with aqueous sodium chloride solution NaCl, it gives NaZ plus MCl2, like calcium chloride and magnesium chloride. Okay, and this zeolite or permutate is again regenerated. So yeah, so you can understand this. So yeah, the zeolite is again regenerated, and so it is like the we can again carry on the process. So let me summarize. So ion exchange method, it is also known as zeolite or permutate method. Hydrated sodium aluminum silicate is known as zeolite. So NaAlSiO4, the reaction is not so important. Just for the sake of understanding, I say that this sodium ion is replaced or exchanged by calcium and magnesium ions from form this compound. Okay, and this is zeolite can be regenerated by treating this compound MZ2 with sodium chloride, aqueous sodium chloride solution. So this is done. So now comes the fourth one, that is synthetic resin method. Okay, so nowadays hardwood is softened by using synthetic cation exchanges. So synthetic resin method, this method is also more efficient than zeolite process. Cation exchange resins contain large organic molecules SO3H groups and are water insoluble. So yeah, let us see this. So synthetic resin method. So you don't know what is resin right now, but you'll get to know when you learn organic chemistry a bit. So so just think, this is the cation exchange exchanger. Okay, this is a cation exchange process. So cation exchange resins contains large organic molecules with SO3H groups and are water insoluble. So for the time being, you need to remember that in the synthetic resin method, cation exchange resins are used, and in cation exchange resins, it contains SO3H groups. Okay, large organic molecules, the SO3H groups. Okay, so this much is only important in this case. Okay, so like just go through the, I'm just going through the process. So ion exchange resins RSO3H, R is a alkyl group. Okay, so RSO3H is changed with RNA by treating with NaCl. So yeah, so when that organic compound or a cation exchange resin, this is known as a cation exchange resin also. So when this cation exchange resin is reacted with sodium chloride, NaCl, so it this Na sodium ion takes the place of SO3H group, and it forms RNA and SO3HCl. Okay, so this is from SO2 plus HCl. This is the thing. So RNA, we convert to RNA. The resin exchanges sodium ions with calcium and magnesium ions present in hard water to make the water soft. So here the R is a resin anion. Okay, so it might be like might call it as an alkyl group, or it's a resin anion. Okay, anionic part. Okay, so on reacting RSO3H group with NaCl, it forms RNA. This RNA reacts with calcium and magnesium ions, forming this RNA reacts with calcium and magnesium ions, forming R2M and plus sodium ions. Okay, so and this thing is also water insoluble, and so it can be filtered out. So, so in synthetic resin methods, cation exchange resins are used. It contains SO3H group, alkyl part with SO3H group. This RSO3H, when reacted with sodium chloride, it forms RNA. This RNA, when reacts with RNA, that's the sodium RNA is a not don't think that's it's a like ribonucleic acid. It's RNA, so it's a compound, chemical compound. So RNA plus so calcium and magnesium ions, that is M2 plus. So M is calcium and magnesium. So when reacts, it forms R2M plus 2N. Sodium ions are released. Okay. So again, in this case, resin can also be regenerated by adding aqueous NaCl solution. So in this case, also earlier we like we learned in the zeolite permutate process that zeolite or permutate can be regenerated by treating with NaCl solution. Here also, resin can be regenerated with NaCl by treatment with NaCl solution. Okay. So this is not important. This is not so important. Just go through this. Just go through this. Okay. This is not so important. This is not so important. Just go through this. These reactions are not at all important. Yeah. Just go through this. Okay. So now comes the most important part, that is hydrogen peroxide. Okay. This is important and many questions come here from here. Very important. Okay. So yeah, this is very important. So hydrogen peroxide is an important chemical. Hydrogen peroxide is an important chemical used in pollution control treatment of domestic and industrial effluents. Okay, let us see preparation. Okay, preparation is very important. Come a lot. Questions come a lot from this section. I think questions are frequently asked from here. So for the first method of preparing is that acidifying barium peroxide and removing excess of water by evaporation under reduced pressure gives hydrogen peroxide. So the first method is that by acidifying barium peroxide BaO2.8H2 and removing excess water by evaporation under reduced pressure gives hydrogen peroxide. Okay, this might come in a board. This is it's a very famous question. So BaO2.8H2. So okay, so it is acidified with considered aqueous H2SO4. So it gives BaSO4 plus H2O2 plus 8H2O. Learn the entire balanced reaction. Okay. So acidifying acid. This is an acid. This is barium peroxide. So okay. So this is acidified barium peroxide. So when this reaction takes place, it gives BaSO4. So Ba plus H2SO4 ASO4. So BaSO4 plus H2O2 H2O2 H2O2. Okay. Plus 8H2. Okay. So H2 H2O2 H2O2 plus 8H2O. Okay. This 8 water of crystallization is removed as liquid water vapor. Okay, this is 8H2O. So now comes the second point. Peroxide disulfate obtained by the electrolytic oxidation of sulfate solutions at high current density on hydrolysis yields hydrogen peroxide. Okay, so peroxidosulfates. Okay, so KSO4 minus. This is a peroxidosulfate group. Okay, so this on electrolysis gives this thing peroxidosulfate. Okay, that on hydrolysis gives hydrogen peroxide. Okay, you need not remember this reaction, but you need to understand the method of preparation also, just for briefing in the board exams. So peroxidosulfates obtained by the electrolysis of oxidation of acidified sulfate solutions at high current density on hydrolysis yields hydrogen peroxide. So this is an acidified sulfate solution. Okay, so this is an acidified sulfate solution. This on electrolysis forms peroxidosulfate. This is a peroxidosulfate. Okay, this thing is a peroxidosulfate. So this that on hydrolysis gives on high, or at high current density gives H2O2. Okay, so sulfate acidified sulfate solution on electrolysis at high current density gives peroxidosulfates. This peroxidosulfate on hydrolysis gives H2O2. So this is a very important method. And this is the most important part, that from where the question comes. This method is now used for the laboratory preparation of D2O2. So a question, they will give you a question like they discuss the preparation of D2O2, and you guys will be thinking that we haven't learned this. This is not in the book. This is not in the scope of the syllabus, but it's absolutely there in the syllabus. And due to lack of guidance or lack of knowledge, you guys couldn't answer. So this is the thing. I'll just mark it here because questions will come from there. That's my guarantee. Questions will come from here. So very important, very important to note. Okay. Okay. So very important to note. So if someone asks you that how do you prepare D2O2 laboratory method in a lab, so you need to answer this thing as peroxidosulfates obtained by the electrolysis of electrolytic oxidation of acidified sulfate solution at high current density on hydrolysis gives hydrogen peroxide. So this hydrogen peroxide, this method is now used in the laboratory preparation of D2O2. So D is heavy hydrogen or deuterium. Okay, we learned in the first part. Okay, so industry, now it comes to the industrial preparation, is prepared by the auto oxidation of 2-ethyl anthraquinol. This question came in Neet. This question came in Neet. It's very important. Neat. This question came in Neat. This is very important. So industrially, it is prepared by the auto oxidation of 2-ethyl anthraquinols. Okay. So 2-ethyl anthraquinol on oxidation. Okay. On oxidation gives H2O2 plus an oxidized product. Okay. So H2O2, this is H2 palladium catalyst. Okay. So don't remember, or this is auto oxidation actually. So auto oxidation term is enough here. So 2-ethyl anthraquinol on auto oxidation gives H2O2. Okay. This is the thing. So let's the first method is that acidifying barium peroxide and removing excess of water by evaporation under reduced pressure gives hydrogen peroxide. Okay, this reaction is very important. Reaction is important, and questions are reaction is asked many times in boards. Okay, so acidifying barium peroxide, removing the excess water by evaporation under reduced pressure gives hydrogen peroxide. Done. Now comes the preparation of D2O2, mainly the laboratory preparation D2O2, that is peroxidosulfates obtained by the electrolytic oxidation of sulfate solutions, acidified sulfate solutions on at high current density on hydrolysis yields hydrogen peroxide. Then this method is now used in the laboratory preparation of D2O2. Okay, D is heavy hydrogen. Okay, this is the thing. And you can also mention this thing also here. Okay, so you can also mention this reaction after mentioning the entire point here. You can also mention this thing here. Okay, D2O, it's just H2, it's like H2O, right? It's a sulfate containing compound. Okay, this sulfate containing compound, it's a sulfate containing compound. So it's a sulfate containing compound, and then on electric it gives peroxidosulfates, and then again on hydrolysis it gives D2O2. Okay, so see, you might be thinking that where K came, what is K? K is just nothing, it's potassium. Okay, so it is given in ionic form here. We are written in compound form here. Okay, this is in ionic form. We have written in compound form. Okay? Nothing else. Okay, if you want to give this reaction, you can give this reaction, and like if you want to explain through this process, you can also explain through this process also. And like question like comes in Neet every year, that is explain the industrial or the state the industrial method of preparation of H2O2 or hydrogen peroxide. So many students confuse this number 3 point with number 1 point. Okay, so and like the NTA generally gives both these points as the options, and students generally make a mistake here and they mark the first point. So there is not the correct path. So the industrial method of preparation is by auto oxidations of 2-ethyl anthraquinols. Okay, this is very important. So in physical properties, so a main thing that comes here is the volume strength. Okay, so numericals come from here. Okay, so numericals come from here. So numericals come from here. Okay, so let us see this thing. So let us understand this through a problem. Okay, let us understand this through a problem, because if you want to understand numericals, then the best part is to study from the problem itself. Okay, So calculate the strength of 10 volume solution of hydrogen peroxide. So you guys might be thinking, what is 10 volume solution? Okay, so 10 volume solution of H2O2 means that 1 liter of H2O2 gives 10 liters of oxygen at STP. So that is the thing. So if any question you are given n volume of oxygen, n volume solution of hydrogen peroxide, that means 1 liter of H2O2 gives n volumes of oxygen. Okay, this is the meaning of the statement. Okay, so if it is mentioned n volume solution of hydrogen peroxide, that means 1 liter of hydrogen peroxide gives n volume of oxygen. Okay, so learn this reaction. This is a balanced reaction. So H2O2. Okay, so H2O2 hydrogen peroxide contains hydrogen and oxygen. Okay, it basically contains hydrogen and oxygen. So hydrogen and oxygen, H2O2, when they break up, it forms H2O, water plus O2. Learn this reaction, because if you forget this reaction, and if you forget to, and don't forget to balance the reaction. Okay, and if you forget to balance the reaction in these numericals, you will be stuck, and you will, the answer will come wrong, and you will get negative marking. Okay, so just remember this reaction, because this reaction you will require in all the sums related to this. If you forget this reaction to balance, or if even if you forget one component, like compound, then you will be in trouble. Okay, so let us see this thing. So what is the molecular mass of H2O2? Say molecular mass of H2O2 is 34 grams. Okay, so oxygen is 16, 32, and it gives 32, and hydrogen is 2. Okay, H2 is 2. So 32 plus 2, 34 grams. Okay, so there are 2 moles of H2O2. So 2 into 34. Okay, so 2 into 34 grams, that is 68 grams, gives 22.7 liters at STP. So from where do we get this 22.7? So you must have learned in the first chapter of class 11, that is mole concept. So that is here you have two moles. Okay, 2 moles of H2O2 gives 1 mole of O2. Okay, so since we are like writing this in the terms of liters. Okay, since we are learning this in the terms of liters, so we'll be converting. So 1 mole is equivalent to 22.7 liters. Okay, so you have done this thing. So 1 mole is equivalent to 22.7 liters. So and this when we calculate the side of H2O2, hydrogen peroxide, we'll be calculating this in grams or mass. Okay, so 68 gram, that is 2 into 34 gram, that is 34 is the molecular weight of H2O2. So 2 into 34 gram, that is 68 grams H2O2 gives 1 mole or 22.7 liters of oxygen at STP. Okay, so 68 grams gives 22.7 liters. Okay, so or we can say that 22.7 liter of oxygen is given by 68 grams. Okay, so 1 liter of by unitary method, we can find that 1 liter of oxygen is given by 68 by 22.7 liters, 22.7 grams of H2O2. And here in the question we are given that 10 volumes solution of so 10 volume solution of gives means it means that 10 liters of oxygen will be produced. So 22.7 is given by 68 grams, 1 liter is given by 68 by 22.7, and 10 liter is given by 68 by 22.7 into 10 grams, that is 29.9 grams, that or approximately 30 grams H2O2. So therefore strength of H2O2 in 10 volume solution is 30 by grams per liter. Okay, so 30 grams per liter, so or equivalent to 10%, 30 by 100. Okay, so I hope that this is clear. So what we can sum up from this point is that n volume, if that the specific it has this quote has a specific meaning, that n volume solution of hydrogen peroxide means 1 liter of hydrogen peroxide gives n volume of oxygen. Okay, so and then we should remember this reaction, that 2H2O2 gives H2O plus O2. Okay, this reaction is very important. If you forget this reaction, everything is finished. Okay, so this reaction is very important. So 2 into 2 moles, so 2 moles of H2, that means 68 grams, so and gives 22.7 liters of oxygen. So 22.7 liters of oxygen is given by 68 grams, 1 liter is given by 68 by 22.7, n liters is given by 68 by 22.7 into n. Okay, that gives the gram per liter strength of H2O2. And if you have to find the if you have to find it in the in terms of percentage, then divide it by 100. Okay, so 30 grams per liter strength, it is a gram per liter strength, and 30 by 100 it gives 3%. Okay, or you can say that it's 30 by 10 also, because it's 10 volumes. So it gives 30 by 10 gives 3% H2O2 solution. Okay, so this is the thing. So this is the gram per liter strength. So yeah, like I was wrong there. So don't divide by 100, divide by the number, like divide by n, like the n volume solution of hydrogen peroxide. Here it is given 10, so you divide by 10. So 30 by 10 is 3%, and if it was n here, any general value, that is n. So if it is n, then 30 by n, that is percentage, that 30 by n percent H2O2 solution. If you have to find in the form of percentage, and if you have to find in the form of gram per liter strength, then this is absolutely enough. You don't need to divide it by n. Okay. So I hope this is clear. Okay. So if you have any problem, let us know. We will be like writing this up in a piece of paper and explaining to you in a Google Meet. Okay. So if you have any problem with this type of numericals, please send in your doubts. Okay. So okay. So now comes the structure. Okay. Now comes the structure. Okay. So hydrogen peroxide is a non-planar structure. The molecular dimension in the gas phase and solid phases as shown. Okay. So it has an open book-like structure. Okay. Remember the term. It is an open book-like structure. How do you open a book or a laptop? It has this structure, right? Perpendicular structure. So it is an open book-like structure. So H2O2 structure in gas phase is dihedral angle 150, 111.5, and H2O2 hydrogen H2 hydrogen peroxide structure in solid phase is solid phase dihedral angle decreases. Okay. So why am I like lamenting on the term gas phase and solid phase? Because in Neet or any other medical entrance exams, this term is like they like generally fool the students by changing the phase. Okay, students generally like the default phase, that is a gas phase. Okay, any shape that we learn is always in the gas phase. Okay, so like H2O2 structure is in gas phase, they learn this thing and they learn the dihedral angle. But in Neet, they will not give you this. Okay, they will not be giving you the gas phase, they will be asking you the solid state, and they confuse the term, and they like mark the option that is for the gas phase, and they get a negative marking. So this is very important here. Note the phases. Okay, note the phases, because note the phases. Note the phases here. So this is a gas phase and this is in solid phase. Okay. In case of water also, you need to find the shape in gas phase and water like in solid phase also. Okay. So in case of water, gas, vapor phase and solid phase. Okay. So you need to like learn the difference between the phase, and you need to learn the phases distinctly. You should not like jumble the like the interchange or interchange the like the datas and like the statistics between the two phases. Okay, so gas phase, its dihedral angle is 111.5, and in solid phase H2O2 has 90.2 degrees. Okay, so both the phases, the structure is a open book-like structure or non-planar structure. Okay, it's not in one plane, right? So it's in two planes like this. So it's a non-planar structure. Okay, or a biplanar structure. So now comes the chemical properties. So these chemical properties you have already learned in like the redox reaction chapters. So you have already learned this thing in the redox reaction chapter, and you are also going to learn the uses and the chemical properties of H2O2 in the chapter D and F block, the reactions in the D and F block. You're going to learn that. Okay. So do not do not like to like I do not like to encourage you to read this thing from here, because it requires a lot of understanding, and mugging up from here will be a tiresome job for you guys. So when we will be covering the redox reaction chapter or the DNF block chapters, you will be getting the things from there only. So no need to learn it from here, because in this chapter it is given in a very short and haphazard way. So do not learn this from here. We will be covering a separate video for this. So do not learn this from here. Okay. So let us move on. Okay. Let us move on to the storage. Okay, this thing is very important. Questions, some give reason questions come. So H2O2 decomposes slowly on exposure to light. Okay, so as we learned in the previous numerical problem, that 2H2O2 decomposes to give 2H2O plus O2, okay, 1 mole of O2. So in the presence of metal surfaces or traces of alkalis present in glass containers, the above reaction is catalyzed and is therefore stored in wax lined plastic vessels in dark. Okay, so yeah, so since we have learned that uh, H2O decomposes slowly on exposure to light, and in the presence of metal surfaces or traces of alkalis, the above reaction is catalyzed and decomposition of like H2O acts at a faster rate. Okay, is carried out at a faster rate. So it is stored in wax-lined glass or plastic vessels in dark. So these questions might come in boards. Give reason, give reason, give reason. Okay, so this question will come and give reasons this year or any other year in the board exams because this is very important. So they will ask you that why is H2O2 stored in wax-lined glass or plastic vessels in dark. So you have to like justify the point that in the presence of light, it slowly decomposes, and in presence of in presence of alkalis present in the glass, or in the presence of traces of alkali or presence of metal surfaces, the reaction is catalyzed. Hence, we cannot store it in like metal or in any glass containers. So wax lined glass or plastic vessels in dark is used because we need to also stop the exposure to light, because light also acts as a catalyst in this case. Okay, so urea can be added as a stabilizer also. It is kept away from dust because dust can all include explosive decomposition of the compound also. So you can also, to enhance your answer, you can also like write that urea can be added as stabilizers. It is kept away from dust because dust can include explosive decomposition of the compound. Okay, so now the uses comes. Okay, in wide scale, it has wide scale use and has led to tremendous increase in the industrial production of H2O. Okay, it has wide scale use. So in daily life, it is used as hair bleach and as a mild disinfectant. As an antiseptic, it is sold in the market as perhydrol. Okay, so this is important. Okay, so in daily life, it is used in the hair bleaches. So when you like dye the hair, you use a hair bleach in the salons or in the spas. So you in those hair bleaches, they have H2O2 because H2O2 has a bleaching action as well. So you will get to know these things. And as I skip this part, that chemical properties, you will also get to know about the questions that comes from the chemical properties. There are very few questions, 1 to 2 in 40 years, but I will discuss those and you will get a better idea and understanding through the questions itself, because these things are not to be marked up. Okay, so I'll be teaching it through questions also. So yeah, let's come back to the uses. So it has used in hair bleaches. It is used as a mild disinfectant. It is sold as an antiseptic in perhydrol. So it might you might get a question in Neet or JE that like name the compound that is present in perhydrol. That is, you will answer that H2O2 is present in perhydrol. This is important. Okay. So it is used in the manufacture of chemicals like sodium perborate and sodium percarbonate. It is used in high quality detergents. So it is used in the synthesis of other chemical compounds such as sodium perborate and percarbonate. Sodium perborate and sodium percarbonate, and those sodium perborate and percarbonate is used in high quality detergents. Okay. So nowadays it is also used in environmental chemistry. So for example, in pollution control treatment of domestic and industrial effluents, oxidation of cyanides, okay, oxidation of cyanides and distillation of aerobic condition of sewage, okay. So just go through this, okay. Like I marked the two most important points, okay. I marked the two most important points here, and you can also mention of green chemistry here because it is trending now. So you can also mention this point, okay. This is very important. Like not so important, I would say. Sorry. So you can just do this thing, and like one point you must include, that is it is used in the synthesis of hydroxychloroquine, okay. Hydroxyquinone or hydroxyquinone or tartaric acid in certain food products and pharmaceuticals, okay. So cephalosporin, okay. This is the thing. So it is used in the synthesis of hydroquinone, okay. So it is used in synthesis of hydroquinone, tartaric acid, certain food products and pharmaceuticals, okay. So let me sum up the uses, okay. So in daily life, it is used as a hair bleach. It is a mild and disinfectant. It is used as like antiseptic as in form of perhydrol, okay. It is used in the synthesis of perborate and sodium perborate and sodium percarbonate. It is used in high quality detergents. It is used in the synthesis of hydroquinone, tartaric acid, pharmaceuticals, and certain food products, or cephalosporin, it says the pharmaceuticals. And you can also mention of it is also used in green chemistry and environmental chemistry also. Okay, so this is not a so important point you can mention because it's a trending topic nowadays. But these two are a must include point if you had to try to answer for board exams. Okay, so we are done with it, right? Okay, so heavy water. Okay, so heavy water is composed of heavy hydrogen. So what is heavy hydrogen? That is deuterium, D2O. So let us see. So it is extensively used as a moderator in nuclear reactors and in exchange reactions for the study of reaction mechanisms. So a D2O we cannot like drink D2O or use it in a household purposes. So it is used as a moderator in nuclear reactors, okay, and exchange reactions. It can be prepared by exhaustive electrolysis of water or as a byproduct in some fertilizer industries. Okay, this is very important. So, like they will ask you like what is the name, the method of preparation of D2O, and this exhaustive. Okay, I'll just highlight it again. This is exhaustive hydrolysis. Okay, so it can be prepared by exhaustive electrolysis of water or as a byproduct in some fertilizer industries. So many students tends to miss out this part, this word actually, the exhaustive, that's exhaustive electrolysis. Okay, so this exhaustive word is very important here. Like just electrolysis of water will not like yield D2O. So you need to mention the term exhaustive electrolysis of water, or else we're not getting marks in the board exams. And if this question comes in need, then you need to remember this keyword, that is it is exhaustive electrolysis and not a normal electrolysis of water. Okay, or as a byproduct in some fertilizer industries. Okay, so, okay, let us see. It is used for the preparation of other deuterium compounds. For example, calcium carbide. Okay, calcium carbide reacts with D2O from Ca2D2 plus CaOD whole 2. Okay, so it is similar to, like you can find similarity with hydrogen. Okay, so calcium carbide plus a 2H2O gives C2H2 plus CaOH whole plus calcium hydroxide. So you can like generally see it's just similar to hydrogen in terms of reactions. So Al4C3 plus 12H2O or 12D2O gives CD4 plus ALOD whole 3. So it is absolutely similar to that. Those are the reactions with water. So you not need to like learn these things and separately. Just replace hydrogen with D, like H2 with D2, and you will get the thing, that is Al4C3 plus 12H2 gives 3CH4, that is methane, plus ALOH whole thrice. These things you know as of now, and don't need to remember these things as an extra thing, but just replace a hydrogen with D. Okay, no change in this thing. But in method of preparation, you need to mention the term exhaustive, or else you're not getting any marks. Good luck, my child. Okay. So dihydrogen is a fuel. Okay. So we had started the chapter with some quotes that like reflect the use of hydrogen as a future fuel. So and we end the chapter also with the topic that dihydrogen as a fuel. Okay. Such a coincidence. Okay. So dihydrogen releases large quantities of heat on combustion. The data on energy released by combustion of dihydrogen, methane, and LPG are compared in terms of same amount in moles, mass, and volume as shown in table 9.5. Okay, so this is the table. If you want to learn or you want to compare, okay, you can do it. Okay, this is the thing. So, why is hydrogen useful and why is everything this thing? So it is just this thing. You can learn it from here. You can just compare it from here. Okay, so in terms of per mole, okay, LPG gives the like largest amount of energy, octane gives the largest amount of energy, then comes LPG, then comes CH4, then comes dihydrogen in gaseous state, and then comes dihydrogen in liquid state. Okay, but dihydrogen is non-polluting in nature, that way it is preferred over LPG, methane, or octane. Okay, dihydrogen is non-polluting in nature. This is very important point. You might be asked that why is dihydrogen used as a fuel? Okay, like why is dihydrogen used like seen as a potential replacement for LPG? That is because it's non-polluting in nature. It can be stored in very small space. It can be transported very easily, and these are the very points. Okay, and it is cheap also. It is not so expensive as LPG and other fossil fuels. and it is a replaceable form of energy because we can create dihydrogen, but we cannot create fossil fuels. Okay, we cannot create fossil fuels, but we can create dihydrogen in our laboratory as well. So dihydrogen is non-polluting, it is cheap, it can be like refurnished or like regenerated, it is non-exhaustible, and it is a very efficient form of energy. That these are the points, like these are common senses. Okay, like you can just like search it on Google and just go through this, because these things are very like, when you like see of an alternative, you look for these things. Okay, there's nothing to learn. I have seen many people learning this point. Okay, there's nothing to learn in this thing. Just like apply a common sense. Why would you use a dihydrogen? Like if it is cheap, right? If it is non-polluting, right? So this is the thing. Let us see this thing in view of hydrogen economy. So it came in our JE. Okay, this, what is hydrogen economy? Okay, this came in our JE as a statement type. JE statement type. Statement type question. Okay. Okay, so this came in our J statement type. So in this view, hydrogen economy is an alternative. The basic principle of hydrogen economy is the transportation and storage of energy in the form of liquid or gaseous dihydrogen. This question actually came, like I just remember right now. So the basic principle, like the main, like they asked in J, that is, what is the main principle of hydrogen economy? So you need to mention that hydrogen economy, the basic principle of hydrogen economy is the transportation and storage of energy in the form of liquid or gaseous dihydrogen. Okay, so this is the main point here. So basic principle is the transportation and storage of energy in the form of liquid or gaseous dihydrogen. Okay, so advantage of hydrogen economy is that energy is transmitted in the form of dihydrogen and not as electric power. Okay. This is one advantage. You might get this in boards. Okay, because it is transmitted in the form of dihydrogen and not as electric power. Okay, energy is transmitted in the form of dihydrogen, not as electric power, so it doesn't require any wires or anything. So yeah, and like the basic, like the we need to understand what is hydrogen economy. So hydrogen economy is a process or which follows the principle of like the follows the principle of transportation and storage of energy in the form of liquid and gaseous dihydrogen. This came in JE also, this came in Neet also, it came in my class 11 ISC board exams also. This is very important. Section, many students ignore this thing, but this is very important here. The basic principle of hydrogen economy is transportation and storage of energy in the form of liquid or gaseous dihydrogen. And advantage is that energy is transported in the form of liquid hydrogen and not in the form of electric power. Okay, so yeah, so we just a summary. Okay, the summary, you just go through it if you want, but I have already summed it up, and I have already like I have tried to repeat the same thing thrice or thrice, same paragraph thrice or thrice, just to clear out the things in your mind and just to save your time, because like while watching the video, if you the things get embedded in your mind, then you save time, and with that time we can solve many more questions. Okay, so, and I've tried that you guys remember the things while watching the video. You don't have to like go and again read the things with your own efforts. But one thing is important, as I told in the roadmap video also, that reading by yourself is very important, and your efforts are also important as equally as ours. Okay, if we are also putting our efforts, you also need to put your efforts, so we can do a good thing. So let us meet in the next video. So we'll be starting with S block. Okay, so S block part 1 and part 2. So we'll be covering that part. So till then, happy learning. Stay connected with us with our website and YouTube. Like we have our app upcoming. So see our social media handles like Instagram, Facebook, and website. And you can download our app, because that our app will have many features like DPP, CPP, and everything. And with the second part, we will be attaching some drive links. With those drive links, you can get access to previous year chapter wise previous year questions from this hydrogen chapter. You will be getting access to DPPs, daily practice problems. You will be getting access to class practice problems. Okay, and we'll be getting some mock tests based on this chapter. So like happy learning, and if you have any doubt on those drive links, okay, just put a comment there and we'll contact you with a contact number. And if you don't want to like contact, like put your contact number there, then you can contact us, that we like in the particular problem that we have doubt, or you, if you want us to solve, you can give your recommendation. So thank you. do visit our playlist. This video will be present in the inorganic chemistry playlist, and check out our description box of uh, part 2. Like not only part 2, not only for hydrogen, in every chapter we'll be providing the drive links of practice problems, questions, previous year questions, mock tests of those chapters particularly. So yeah, happy learning. Thank you.